Hello, everybody. We're going through the usual things with the modern working environment, where they've been chopping down trees next door, but hopefully it will remain quiet for the duration of this talk. This is a deep dive on autonomous economic agents and where we are with the framework, how to build them, all the cool things we've got, a little bit about what we're doing with them. I'll be doing more of a shallow dive at the beginning with some of the use cases and things like that, and then David will come in and go into a lot more detail about how things are going on. Okay, so firstly, for most of you will be familiar with Fetch, but for those that are not, a brief introduction to what it is that we do. Fetch is about harnessing the unused power and utility in the economy, and there's a lot of it. There's a lot of data, a lot of information, a lot of intelligence, a lot of bits and pieces that go to waste, either because we don't know it's there, or it's too costly to actually find it. What we do is we break the economy down into all of its individual component parts, and we bring those to life, and we call those things autonomous economic agents. And they're representatives of things such as services, devices, people, data, and anything else. And we have a search and discovery mechanism, which effectively acts as a dating agency, connecting all of these agents together, so that agents that are likely to want to work together are connected effectively and easily and efficiently. And there is AI across the board in this architecture. Not only is it using AI, so for example, in search and discovery, as time goes on, we're introducing features that can learn which kind of agents want to connect to which kind of agents and when, but it's also enabling and providing it. So it enables agents to provide intelligence and other services to other agents, and those are then provided to all of their users to benefit from. The Fetch token is the fuel for agents. It enables agents to perform computationally expensive operations in search and discovery, such as, for example, semantic searches, for them to run smart contracts, and also it is the unit of value exchange. All of this stuff is available now. Code works, agents are real, documentation is excellent. And as of yesterday, we'd served a total of 171,000 autonomous economic agents through the search and discovery system. Over 100,000 search queries, over 400,000 individual agents have been found. And at its peak, we had over 5,500 agents on the system of varying types. So what is it that we could do with all this stuff? Well, it's about, and we call this last mile logistics. It's something we're doing in our decentralized delivery network. It's about all of the complexity that happens when you get to the edges. And it's about local, context-sensitive problem solving. And this stuff is really difficult. And if you're able to connect all of the things locally together so that they're able to get things done without centralized command and control, then effectively you can scale that system much more. We're also using agents to bring to life the world around you in order to augment or create an augmented reality for self-driving cars. This stuff is really important because AI on board vehicles is very difficult. It's very complex to recognize the world around you. But if you have autonomous economic agents representing signs, junctions, and other things, and we did a demo of this over the summer, actually built a working example of how this might work, then the augmented reality actually makes this a lot easier. It makes it more likely that we can reach true self-driving vehicles a little bit quicker than we otherwise would. It's also about providing a common interface to all of the information that's out there, so that even with no prior exposure to or no prior knowledge of other things out there, you can incorporate it into your solutions. And it's about delivering value autonomously and actively. So the value that you've got goes out there and finds things that it will be able to deliver it to, as well as things that might want your stuff but actively delivered to you. One of the things that we've been building, we've been talking about a lot on a previous Crowdcast, and we've got a number of blog posts about it, is our decentralized delivery network, which we refer to as delivering people, pizzas, and packages. It's about creating a scalable network where all of these things can work, and we can create a network where the value is provided and delivered back to those that are actually doing it. Now, agent-based decentralized architecture has a bunch of advantages. I'll just skip over some of these, but when you're dealing in a large population of simple things, you get a degree of robustness and security and safeness, because it's much easier to secure simple things than it is monolithic, huge, complex things. But also, of course, you get the flexibility of those things being able to reorganize themselves dynamically in order to change to an adapting world. And if there's one thing that 2020 has taught us, well, there's probably a few things that it's taught us, but the world can change very, very quickly indeed. And large, complex, centralized systems find it quite hard to adapt to that. But individual small agents that are representing individual parts of the economy can rearrange themselves in different ways in order to adapt to the environment that they find themselves in. And also it's local solutions, local problems and local solutions. This is important in delivery. It's important in, for example, energy supply and many, many other things, and providing an incentivization mechanism for people to take part. When you can, for example, make your own agents that connect to the utility value that you have, and they can just sit there and provide you with an income for delivering that value to others, then that's a worthwhile thing to do, so long as we can make it easy enough to do that. Here's a diagram that sums up the structure that I've just been talking about. This was originally a video, but videos don't come out very well on Crowdcast. But just an example, on your left, you've got a bunch of agents. On your right, you've got a bunch of agents. But the one on the right are going to communicate with each other about their local environment. And when they do that, they're able to solve the maze much, much quicker than those that are working independently. We have demonstrated this many, many times. We've been part of working this e-mobility challenge, but after that, we built a simulation that showed with 200 vehicles driving across Europe, we were able to shave 30% from the journey time and reduce congestion at the charging points just by allowing those agents to talk amongst each other locally in order to pick the optimal time to get things done. So the use cases we've got right now that we're actually building, hospitality in development. And this is about ensuring that all of your hospitality needs, all your hotel needs are solved for you. Supply chains, we've been working in conjunction with the University of Cambridge in optimizing those with autonomous economic agents. Our decentralized delivery network, which is about returning control and value to those that are actually delivering the value in that network. Zoning, which of course is about being in the right place at the right time. Charging and parking, which we've talked about, and also energy optimization. Now, of course, if you're able to make better use of the assets that you already have in the economy, then that's good for the environment. It's a lot less wasteful, and you can end up with smarter solutions by incorporating information that you wouldn't otherwise do. And of course, it may not have escaped your notice that you can join all of these things that I've just talked about together into one grand network and bring entire smart cities to life and solve all of these problems in one huge thing with a very, very large population of agents. This is just a small screenshot of the decentralized delivery network running locally around Cambridge. This has been running 24/7 now for quite some time. This is just showing individual vehicles, passengers and delivery points. We're also running this in other locations as well. At various points, we've had several hundred individual component parts involved in this. And what's really cool about it is any one of these individual components, the people or the vehicles, you can inhabit as a real person, and we can effectively take control of the network from the simulated parts and actually drive around and pick up real people and do it. And that's part of showing how this network will work. And we're very excited to be able to talk more about that in the coming weeks and months. Okay, so we live in a very complex world. There's more and more moving parts, and delegating problem solving from a central position in a trustworthy environment is hard to do. But when you start talking about technology such as non-fungible tokens, verifiable credentials, breaking things down into autonomous economic agents, then it becomes realistic to manage all of that without any centralized point. And then those individual parts can adapt to the world around them. And actually, given the speed of things, being able to change the solutions that you've got immediately to solve local needs is extremely important because things change fast. And it's the same with applying machine learning on these networks. Having access to all this information to get the benefits from that learning promptly is extremely important. And Fetch agent technology helps with all of this stuff. And also, of course, we try to make it easy to use to encourage adoption. If you're able to, for example, as a commercial entity, you're able to try out agent-based solutions without having to take apart any of the solutions that you've already got, either to augment what you've got or to run in parallel alongside it in small areas, then it reduces the risk of attempting adoption. We think that is extremely important as well. Quite apart from the fact decentralized networks mean that there's no risk of a centralized owner ever removing access. So you can do these localized focused trials, and we are in a number of cases. So incentives. So the FET token is the essential fuel for all agent actions. that value is actively and not passively delivered. And that's a really important key point of this. The agent framework that we built, that David will be talking about in more detail in a second, does 95% of all the heavy lifting required in order for you to build and deploy your agents. And what's really interesting about it is your agents, without you having to know about it, can contribute to other people's solutions. And likewise, other people's solutions can contribute to yours. And it's that passive income from the otherwise wasted utility value that's so important. So a couple of little things before I hand over to David. Our OEF, which is our search and discovery system, this is up, running, and connecting agents. I went through some stats at the very beginning. It's a very simple connection model right now, but it's getting more advanced every single day. The agent framework incorporates it at a fundamental level and makes it really easy to access. We're building a web-based interactive explorer at the moment, so all of you can walk around that world. And I have to confess, one of these days, I'd quite like to render that in 3D and stick a VR helmet on just to see what an agent-based world actually looks like. And we're collecting some fantastic data about what happens in this world. So we're going to present some of that in graph and chart form over the coming weeks. And who doesn't like a graph and a chart? And explorers are quite easy to write as well. In fact, for those of you who are in Telegram, our Telegram channel on Sunday, I took it upon myself to create this. The little purple squares, it doesn't look pretty because it's programmer graphics. The little purple squares are all the cities and towns. And the little unfilled in ones represent agents. You can actually see in this particular case, stuff going on with hospitality agents and also the decentralized delivery network doing its stuff. And of course, agents should be buildable by everyone. There should be no barrier to entry. And so I'm just gonna, as my last screen, show you a little something that we're looking at for 2021, which is the Visual Agent Builder. This is really interesting because those of you who have seen programming in languages like Scratch will know that actually it's quite easy for non-programmers to be able to drag and drop a whole load of things together and make surprisingly advanced things. And what's interesting about this is you can wrap up what you do in the agent builder and turn it into an agent that somebody else can just use. And if they want to customize it, then of course they can go into the agent builder to see this stuff in more detail. And we think this ability for anyone and everyone to be able to create and deploy agents and get the value from doing so is extremely important in both building the agent population and also seeing some of the amazing novel solutions that can be built with this technology. And that's enough from me. And now I'm going to hand over to David, who's going to go through all of this in a little bit more detail from a technical perspective. David, all yours.
Thanks, Toby. Let me share my screen now. Okay, well, thanks for being here, everyone. Thanks for this high-level overview, Toby, and telling us about all the projects which we have in the pipeline and our partners are working on. As Toby was pointing out, this is an open endeavor. We're building open source software here, and we're building tools for code to be shared in the form of the AAs here, but also tools around AAs. And therefore, having a community is so fundamental. That's why we have this call today, and that's why we want to continuously having these calls. You can access us, obviously, on Slack to talk to us there. We're setting up a bunch of other channels. Toby mentioned Telegram. We are both also on Twitter. So please do engage with us if you have any particular questions which might not be covered by this call. We're always happy to answer those. So I would like to first start off on a very brief sort of high-level overview of what we mean by AAs, and then introduce you slowly to the framework. And as I go through the slides, there aren't many of them, I will occasionally show you how to install things and how to interact with the framework. At the end, we will have ample time for questions, and I think you can already deposit them here on the side. So what do we mean by an AA? Well, it's an intelligent agent acting on an owner's behalf with limited or no interference, and ultimately whose goal it is to generate some economic value for this owner. So that's a very sort of theoretical definition. And I will take you through what this means actually in terms of code. And the key thing here to note is that firstly, AAs act independently of constant user input. So there isn't a user who constantly has to click around on some interface to cause some outcome. The agent autonomously executes actions to achieve a prescribed goal, which is prescribed by the user at some point. So it's important, therefore, to understand that what we mean by AAs is not just any agent. So particularly, we have built software which is meant to be deployed in a sort of multi-stakeholder environment where there are competing incentives between the agents. So the agents are owned by different economic entities, and they pursue their own individual goals. There's no centralized entity which kind of coordinates all the agents. That's very key to understand and sort of underlies the whole design of the framework. It's also what sets it apart from multi-agent systems, and I'm happy to discuss this in the follow-on. AAs are also not just APIs or sensors, because those don't have any agency normally. AAs are also very different from smart contracts. I'm mentioning this because we're obviously in the DLT space, and it's pretty important to understand the difference. A smart contract lives or is executed on some decentralized ledger or blockchain, and is therefore poorly reactive, waiting for external transactions or request contract calls to arrive. An AA is running constantly and displaying proactive behavior. And I'll show you what this means in terms of code in a moment. And finally, I think it's also important to not get worried that AAs are some sort of untractable piece of software which doesn't yet exist or might only one day exist. So it's not to be equated with artificial general intelligence. An AA can implement very basic logic, but which is useful to the owner and delivers economic value. So for instance, as Toby was mentioning, if you have a sign being represented by an agent, so a street sign, that logic might be extremely simple, but it delivers value to those cars which pass by or other scenarios. So an AA framework, we have a bunch of papers coming out which define this on a technical level. This isn't the point to discuss them here, but it's important to, from our perspective, to differentiate that there's some code, some implementation of a framework, and then there's the concepts. The concepts are generic, and we think you can implement them in lots of programming languages. We've started out implementing them in Python simply because we needed to be able to iterate a lot and quickly, which Python does allow us to do. But obviously, some applications we have in mind will require different programming languages, but the AA concepts will translate to them. The framework is very modular and extensible and composable, and I'll explain in a moment why that is so. And the kind of notion I would like you to maybe think about, what we're trying to achieve here, is that we're trying to deliver a framework which does to agent development, particularly AA development, what web frameworks did for web development. And that means we want to lower the barriers to entry a lot. And we might even go as far as Toby was saying that actual non-coders can at some point assemble AAs. So there's 3 core resources at this point in time which I recommend you have a look at. So firstly, the documentation. The documentation. We can basically find this if you navigate to docs.fetch.ai and /AEA. And I will, in a moment, talk about a few of the key concepts which are mentioned here. The second useful link is obviously that of where we have distributed the software on PyPy. We can download this from there, and then there's a very helpful quick start, which I will now quickly show you parts of. So the first thing to know is that the AA in its current form can be run on all 3 major platforms: Windows, Ubuntu, the Debian, and macOS. And you will need Python 3.6 or higher, as well as Go 1.14.2 or higher installed. We utilize Go in some places where we have a lot of networking requirements. And so that's why this requirement exists. I've already prepared an environment, so I'm going to skip over this. And once I've got a development environment ready to go, all I can do is essentially install this library, right? So I've got a virtual environment here, which currently doesn't contain anything other than the sort of standard pip dependencies. And we can now get the latest AA version, which happens to be 0.6.1. I'll let this install for a moment. We recommend you always install it with the all, because we have a CLI tool and some other tools which are attached to it, and it just makes it easier when you follow through the documentation. But if you get more familiar with the framework, you can have a lighter weight installation, which kind of drops the all here. Okay, so one thing before I continue here in this guide is I would like to talk a bit more about some high-level concepts. So as I was saying, or actually I wasn't saying that, but I was saying this is very componentized. But one of the core reasons why the framework is composable is that all the components mostly interact via messages. So there's very little state which is shared between those components, and all the interaction between them happen via messages, which means that in effect we have a sort of actor-like framework design. And there are four core components which a developer worries about when developing an AA. And the beauty of this componentization is that, and I'll go through what they are, but the beauty is that, as Toby was saying, someone might develop either one of those components and be able to share them, and then they can be reused in another project. So we have a built-in way to distribute them. We'll come to that. So the core component, the four core components are protocols, connections, contracts, and skills. Protocols essentially define the interaction protocols within agents as well as across agents. So this means they define what the messages look like, what their contents are, how you serialize them, how you decode them, and they define structure over sequences of messages, i.e. dialogues. The second core concept are connections. So what do we mean by connections? Basically, we separate all the networking aspects and interacting with the external world into its own component, again, to make it modular, so we can just drop it in and remove it again. So connections wrap SDKs and APIs. And for example, you would have a connection which lets you talk to other agents via the network, or you would have one which lets you talk to a given ledger, multiple ledgers. And you might have one which lets you talk to your own homegrown API. And what you can do is, if you're talking to directly via the network to other agents, you can simply utilize our protocols. If you're talking to other agents, other services which aren't agents or aren't aware of this paradigm, then what these connections also do is they translate between the types of protocols. So you might have a HTTP client which does some request to the AEA, and the HTTP connection would then be responsible for turning HTTP request response cycle into this message-based paradigm, dealing with creating the response and then itself. The third core abstraction are these contracts, and by contracts, we basically just mean wrappers for smart contracts. Basically, here you would place any logic which sort of helps you abstract some of the underlying specifics of that ledger where the smart contract is deployed. And so it allows you to, again, have this capability of dropping in different contracts without breaking any sort of the other components. And finally, the most important one, which most developers actually spend their time on, is skills. So here we implement some business logic specific to a purpose or a given goal we want to achieve. If, of course, I mean, this was extremely high level, I don't expect you to sort of go away immediately now and understand this all, but we have very detailed guides here, where you can have a look. Sorry, I need to move my mouse. So there's 2 links here which you can have a look on the documentation. And I want to quickly say something about AAs versus web development, just to kind of anchor the paradigms a bit. So in the web world, we, at least the traditional web frameworks, they often have this model view controller kind of architecture, where the model holds a lot of the data and business logic. The controller receives the requests and then handles them off to the model, and then the view is the representation of what you display to the user. And there's a certain analogy to how you can think about an AAA. So a skill will have a lot of handlers. And these handlers are reactive in the sense that they are given messages in a specific protocol and then can deal with them as implemented by the developer. And so they sort of model this concept of a controller in some sense. You've then got tasks, like in web frameworks, we allow you to spawn background tasks, etc. We have the model, again, very similar to the MVC, where we have data representations and business logic implementations. And then the key thing which differentiates us here is the behavior. So in a normal web app, I mean, the web app itself wouldn't have any objective. I mean, the business who owns it will have it, but the web app won't usually go and do stuff. I mean, you can make it do stuff, but most won't. They will be purely reactive to user input. And that's what our framework obviously is centered around. We want the AAA to do stuff for you. So it needs to have some sort of concept of behaviors, the proactiveness, where it initiates, for example, a negotiation with other agents and things like that. Again, there's a link below where you can find more information on that. So this is the potentially daunting picture, and I'm not going to go on it, but you can have a look at it in the end. Which boils down pretty straightforwardly in that we have a lot of messages which are being passed between these components. And as a developer, you mostly have to understand what a skill does, i.e. what I was introducing here. So that's it for the kind of high-level introduction of the AA framework. I want to get a bit more concrete for the remainder of the time. So we were saying, or Toby was saying, that one of the key objectives here is to have a lot of applications supported, and a lot of these applications supporting each other with code, as well as through the agent's activities. And in order to at least satisfy the first, the second part with the code, we need a way to share code easily for framework-specific code. And that's why we have built specifically for the AA framework a registry which allows you to share parts or entire agents. So this is accessible as of recently under this URL, and we can have a quick look here. So it's essentially an index. You can search for different projects. So you can search for entire agents. You can search for connections, contracts, protocols, and skills, the components of them. And what I'm going to do is I'm going to say, okay, maybe we have something like my first agent. We don't have that, but what about my first AA? We do have that. And I want to see what I can do with this now. So it's telling me already what I have to do. I have to basically fetch this simply. I've installed the framework already. So what we can do is we can verify that we actually have the framework installed. So let's quickly do a version check here. So I have a lot of stuff running at the moment. Here we go. And now what I will do is I will be able to, this is the latest version, as I said, 0.6.1. What I will do now is I will be able to fetch the latest My First AA project from the registry, hopefully. And you can see that this has worked out fine. So what has it done is it's gone and made a simple HTTP request to achieve the download of a bunch of these dependencies. So it first downloads the agent project. We can have a look at this. So an agent project is defined by essentially just this configuration file, which specifies its dependencies. And all these dependencies have also been downloaded, as you can see here on the right-hand side. And they have been placed under the vendor in the relative positions. So the connection was stub, the default protocol, and the echo and error skills. And I can now already run this agent. And we will see that it's telling me the current version. And this is an extremely simple agent. What this does is the quick start agent. And all it does is it loops over the act and react components, so the handlers and the behaviors. And here currently, when it's acting, when it's making something, doing something proactively, all it's doing is printing something to the standard output. So this is very basic. But what I can now do is can see what happens if I were to interact with this. So I'm opening a second terminal here, going quickly in my virtual environment again. We have this, just for demo purposes, this tool called AA Interact, which lets me actually, oh yeah, I'm not in the agent project, so my first AA, which lets me interact with my running agent here, just for the quick start. This is all its purpose, and it's saying provide me a message of a given protocol, performative, and I'm going to do this. So I'm going to say hello. And what it's done is it's sent a message to the agent with hello. And we can see that the agent handler has received that message. And actually, all the agent handler does, it bounces this back. So if I enter again, I see that I have received actually the response here. So the sender now being right. So this is just to demonstrate in a very basic way the two core abstractions skill developers are usually familiar with, which is behavior and handler. So now I would like to return to quickly the discussion of the registry. So firstly, as I said, we can download, I demonstrated this, packages. We can download entire agents as well as individual components. So let me demonstrate this quickly. So we had here our agent project, and let's say I want to now extend this further. So I'm just going to pick some random skill. So we've got this trading agent competition, and I'm going to pick a skill for that. Let's see that one, and I can then basically add that if the versions match. Yeah, they seem to match. And so you see this is a bit more complicated skill. It has a few dependencies, and then they're automatically fetched. So this is what we would expect from a registry. It basically just lets me compose these projects from finished pieces of or finished components, which then arrive here and are referenced in the AA file. And then what I can do is I can publish again a new project with the respective commands. So I can push push individual components, or I can publish entire agent projects. So please do check this out. And in particular, please start adding your own projects. So we obviously have a growing community, and we know lots of you are already sort of currently sharing their projects on GitHub. Now you have the ability to do this via the registry, and that allows others to contribute to your projects and reuse parts of your projects. And this is particularly important, I would like to say, on the protocol side. So if you think about what we were saying earlier, how do agents interact? Well, they use these protocols. And at the moment, as we're growing the project, we're still restricting a bit the way agents use these protocols, so they have to match quite a lot. And you can, for example, now implement a protocol for a specific purpose. For example, the energy trading project has its own. I mean, all the protocols, all the projects have their own protocol. But for example, energy trading, you can have a specific protocol which you utilize in the scenario, and then all the agents in that which want to participate in energy trading can use these protocols to interact. And in fact, these protocols aren't tied to Python at all. We are able to add more language support there very straightforwardly, because it's all utilizing a protobuf in the backend for the serialization related logic. So finally, one question which we get asked a lot, and I think is really important, is like, of course, once I've developed these things, how do I deploy them? And I just will say a few words on that. One most obvious thing for local development and local demonstrations is that I run them locally on my machine. So for this, we have the most support, naturally, because as the project grew, that's what we needed the most in the beginning. And we have this extensive CLI, which has, I think, over 30 commands, which let you manage the project. And we're continuously expanding this to run fleets of agents and different configurations and things like that. There's then a GUI as well, which we are heavily updating in the coming weeks. So this is the precursor to the project Toby was announcing for next year. It's to begin with a simple way of building your agent from finished code, i.e. packages, in the browser, but ultimately it can grow into a much more advanced no-code kind of tool. You can run an AA straightforwardly on a Raspberry Pi. A lot of the team members do that. Actually, it's a lot of fun. And actually greatly utilizes the Raspberry Pi. I think they're perfectly, like, imagine having, because essentially you've got like decentralized code and decentralized hardware. I mean, can't get any better than that, probably. And then finally, obviously, you can run it in the cloud. The project has a lot of guidance on how to do that. And please reach out to us if you have any particular questions. There's Docker images to do that, which we have prepared for you. And I think that's it from me. I would like to answer questions. Toby, what?
Yes, we've got quite a few questions, actually. Are you able to see them all?
Yeah, do I have to scroll up?
No, you just have to click on the bit that says ask a question at the bottom of the window, and then they'll all pop up. There are some really good ones here, folks, so we're going to crack through as many as we can. The top one with 4 votes is, will people who don't know how to code also be able to create autonomous agents? The answer to that is it will be possible, yes. And I can give you an example. Imagine that we've got our hospitality and DDN networks up and running, and you run a small independent hotel somewhere in the south of France, and you wanted to connect your hotel to that network so it can be discovered and booked by other autonomous economic agents out there representing people. Then the person owning that hotel is not going to want to learn how to program in order to do that. They're going to want to be able to grab a component that pretty much does it, make a few little configuration changes, and then press a button, and everything needs to be done for them. And that means that all of the different connections, and David went through all of these, the different bits that are responsible for connecting to different protocols and so on and so forth. They will have to be able to get very easily the ones that connect to the very standard and well and commonly used hotel backend systems, drag all those things together, connect them all together, and be done. So we need to make it easy. We also want to be able to encourage people to play. And one of the things that we've seen in visual programming languages like Scratch, for example, is that it encourages people to play, because you can drag a few things on and see things visually happen very quickly. Whereas if you sat in front of your average PC these days and tried to do that, get some things on the screen in a 3D engine, it would be months before you'd got to the back of all the frameworks you needed in order to be able to do anything. So it's making it more accessible that is extremely important. But also, even with limited programming knowledge, what we've got now with the AEA registry and all of the CLI tools and everything else does take, as I said on one of my slides, it does do all the heavy lifting for you. You only have to type a few things and you have a basic agent and they're able to talk to each other. And then you can incrementally add little bits to that. And before you know it, you're on the OEF and you're finding other agents and you're getting things done. And you can plug it into whatever services or sensors or anything else that you have access to, or web APIs for prices and weather and this, that, and whatever. So it's very easy to do. Any thoughts, David?
Yes, no, I would support what you said. And I think we are obviously on a journey to achieve towards exactly that goal. I mean, there's the journey to improve the tools we have for the developers, and there's the journey to or the efforts to lower the barrier to entry for any given individual. And I think we get a lot of input from the community who works with our tools, and any particular input you have as you work with our tools will always obviously be very appreciated. How can we make it easier for the developers we already have and for people who might not be comfortable with developing?
Lovely. And of course, it's in our best interest because there's a lot of people who'd like to try. And if we make it easy to try, then it's easy to do. And every agent that's on the network wanting a piece of value or delivering a piece of value is one more thing that can be found and used by other people who are solving problems. There's a question here which I really like is how would you explain an AEA to your or my grandmother? And the extra bit on that is I'd like to use it in conversations with C-level managers. That's a good one. To me, there's lots of different ways of stacking cats, of course, but the agents that most people will interact with are the ones that represent them. And most of us aren't rich enough to have personal assistants and butlers that look after all of the problems in your life and make sure that the things that would normally get in your way are got out of your way without you having to think about it. But with autonomous economic agents, that's no longer the case. That kind of ability to solve problems is now available to everybody. So you can think of them as personal assistants. You can think of them as little digital people that are going out there and negotiating with other little digital people in order to solve problems, be it energy, mobility, hospitality, or anything else for that matter. So I think that's one way of putting it. David, would you like to add to that?
Well, I like that, and one other way to look at it, or probably the same, I don't know, is I mean, on a technical level, it's software that works for you, which isn't the explanation you would give the grandmother necessarily. But I think when we usually say that, what people say, well, all software works for me. And in some sense, that's true. But you have to ask the question, who benefits most from, who extracts most of the economic gain from that software working from you? And it's unfortunately no longer the case that is usually you. Usually you give a lot away in order to use very simple services like messaging, sharing things with your friends, shopping online. And I think what the AA ultimately does is it wants to return more of that value capture back to you. And the way this could happen is if we work together and build AA components, which can be shared around by developers, between developers and between individuals, and can be just dropped into your own AA, which you run locally, where you no longer rely on some central huge corporate, which extracts most of the value. So it's a different way of software working for you, really for you, not just for you a bit and a lot for some corporate.
And it is very much a case of turning the world inside out. As Dave was saying, you don't have to go out there and look for stuff. The stuff that's important to you will come and look for you. And even better, something that represents you, that belongs to you, is owned by you, controlled by you, that understands you, is out there doing all of that negotiation on your behalf. I think that's pretty cool.
Yeah, I mean the number top question right now we should also address.
Edge devices.
On edge devices. So there's several answers to this. So as I said, AEA, the concept, is currently implemented in Python, where there are certain limitations. But AEA, the vision, absolutely yes. And we have limited support for edge devices already with some of the Go libraries which support the current Python implementation. And there'll be much more to come. And I'm sure Toby can say much more on that.
About which bit, sorry?
The AEA is running on edge device.
Yeah, on edge device, of course, routers and things like that. For those that support that kind of thing, and where there is a benefit to doing so, there is absolutely no reason why that shouldn't be the case. And obviously, it's in our best interest to allow AEAs to run on as many devices as possible, be them routers, IoT devices, or anything else for that matter. So coming up with mechanisms for doing this as computationally and resource cheaply as possible to allow that to be possible is one of the many things that is important. And as David has said, whilst the current agent framework is built around Python, that there is no reason, because of the underlying protocols such as the peer-to-peer communications that the network uses and everything else, the underlying protocols can be done with any language. So of course, there's great scope for implementing this in different ways so that it can be run on different devices.
Yeah. So the next question there, I really like to say something on leading on from what you just said, Toby, peer-to-peer. So the question being, why will developers build on Fetch.ai platforms? So if you're thinking about agents specifically, it's actually a daunting task if you don't have support for that. So that's where we found the company found itself in a while back. So one example is just finding other agents, right? So you could say, well, there's the internet and that lets me connect to anything, but that doesn't really solve the problem. You need to find the right agents, you need search and discovery, and then you need a way to communicate them if you know their identity, i.e. some cryptographic address derived from a cryptographic keeper. And that's one problem we solve why developers today use our tools. The other one is the thing we've been banging on about in the talk all the time, which is sharing code. So I've seen so many projects which, interacting with some blockchain have some dedicated code, and then the next person wants to reuse that to interact with a set of smart contracts, and it's basically, unless they read the entire code, it's hopeless, impossible. And interacting with this decentralized ledger technologies is very, very taxing. I mean, I'm sure there's lots of very much more experienced developers than me in this channel who have worked with these technologies, but for the average individual, and even for them, it's very taxing. And that's where this kind of wrapping certain capabilities in these concepts and reusing them helps a lot. And we've got actually an entire presentation and paper on why we think that AEAs are perfect second layer technology for blockchains.
And of course, the underlying ledger and everything else that we're building, particularly as the journey towards mainnet version 2, it's designed as the perfect home for autonomous economic agents, supporting them in exactly the way that keeps them cozy and happy and able to get their work done effectively. And when you're talking about very, very large populations of autonomous economic agents in the future, having a network that is designed to work around them, to facilitate the large numbers of potentially relatively small value transactions, to support the kind of smart contract stuff and all the other bits and pieces that we're talking about, such as the search and discovery, then that's very, very important. And since we're just to tag another thing on, depending on which angle you ask that question from, so why would you do it? Well, because agents can potentially interact with other agents with no prior knowledge, you can build an agent that will take part in our hospitality network or our DDN, and you don't have to ask us permission to do so. So if you run a little guest house, then there's no reason why you shouldn't get the right classifications, build an autonomous economic agent, deploy it, and then suddenly appear in all of the tests that we're doing as we're building that use case. And that ability for you to deliver your value into something where it is useful and can be delivered and then receive FET tokens for doing so is one of the reasons why this becomes very attractive as these applications grow, because anybody can be part of them.
So there's one question on evolving message contracts formats can be understood by all agents. I like this question because it's very important. How do you ensure that as this ecosystem grows, these things actually stay interoperable? And we're at the very beginning of this journey, and the way ultimately we're achieving this is by the way we're designing the protocols. So the things which are currently sort of used by our developers rely on these versions matching within certain ranges between these protocols, and then there's ways to resolve between these protocols. But we have in the works some ways to automate these processes further, because ultimately these protocols have very well-defined graph structures. So there's a lot of automation you can build in to find out how certain protocols relate and whether a certain agent might actually understand this protocol, which happens to be a sub-protocol of another, and things like that. And with contracts, it's a bit more a bit separate. So contracts are much more obviously tied to specific ledgers. So at the moment, the way it works is that we have some examples where we use smart contracts and AAs, and if we want to use different ledgers, then we maintain internally the same APIs, but then implement under the hood these different specific contracts. Again, this is obviously just the beginning of the journey. There's a lot of thought and automation you could put in, but ultimately you see that we're not attempting to solve every problem under the sun here. We're not trying to say, okay, Fetch will solve every given problem for you in agent development. What we're trying to do is to say, well, here are the rails for the community to coordinate to solve these problems. And we will continue contributing and building some of the key tools and so on in the ecosystem, but it is a shared effort.
How many, this is a good one, how many autonomous agents can exist on the Fetch.ai network? Well, how many do you want? One of the advantages of this decentralized bottom-up approach is there is, in theory, no limit at all. This can scale and scale and scale, and this is extremely important. In fact, it's an incentivization for further decentralization, particularly when it comes to search and discovery and individual network nodes, because in order to serve that number of agents, there is an incentive to create all these additional nodes to do that, because there's only so much capacity in any given search and discovery node to deliver those services. And of course, what's interesting about that is the more of these nodes that appear, the higher resolution the network becomes, because if you're organizing your network geographically and semantically by positions and meaning, then eventually finding the node that represents or is most likely to have the agents that are going to serve the needs that you have is very easy to do. So we imagine, particularly with things like DDN, when you start thinking about DDN and hospitality globally, then you start to imagine the kind of sizes that we're talking about. And these are very big sizes. So what was the number? I mean, when I was processing a number of cities, a number of large cities, and seeing sort of 128,000 of the biggest ones above a certain population level, you imagine just how big the world is. And when you start thinking about some of these applications, then that's a lot of agents very quickly. So it's very important to build something that, in theory, can support these kind of huge populations.
Yeah. I mean, obviously, one thing which helps both with this question and the other one on
the computational power one.
No, how quickly can AA process messages? Blockchain can be rather slow. Like the bottleneck, obviously, for the blockchains is the consensus. So the AAs here, I mean, they're independent entities, and they are black boxes with respect to each other. They could potentially participate in some consensus somewhere, but they can also not. So unlike a blockchain, there isn't like a fundamental sort of scalability problem here. As you add more resources, you could scale it up. Toby, any on that?
No, I was just going to say there's another question on here which is quite good, which is if you imagine an application where many thousands of consumers use, will everybody be required to buy FET tokens? Will be another way to make it accessible? Well, you see, this is a very interesting question. I quite like this one. I like this because actually really good technology, well, I misquote Douglas Adams every time. I'm sure many of you have heard me do this before, but people don't want technology. They want to get things done. And the best technology is invisible. It's there solving problems for you without you having to understand the intricate details of what's going on. I believe that most people's first interaction with a FET token, they'll never even have known that they had one. Autonomous agents will gateway in something that they're already familiar with. Maybe 1,000 agents will perform the transactions they need to in order to prepare a solution with maybe smart contracts and other things involved, numerous search and discoveries. The results will be done, and then something will come back. It needs to be super easy for people. If they have to jump through 100 hoops of learning a million things before they can take part, then it's very, very difficult to get that adoption. But of course, this is a job for an autonomous economic agent. And we often thought back when we were considering this initially that they can act as gateways between different networks, different processes, ensuring that the pain points that would normally get in the way of this stuff actually working are made invisible to the end user.
Yeah. There's another two technical questions which I'd like to get on. So do your agents have task planning or any AI capabilities to allow them to be autonomous, and so agents can interact with any smart contract platform? They're somewhat related in the sense that the way we think about this from the AEA framework perspective is that we provide certain hooks for extension, and we provide minimal extensions, which obviously we improve as we go along. That's basically the answer to both of them. At the moment, as I said in the presentation, an AEA can essentially have no advanced reinforcement or deep learning or any of this or task planning in it. Can just be very basic, responding to messages and ever so often send a message or something. But it can also do these other things. At the moment, the framework basically supports you to implement these other things, but it doesn't implement them for you yet. Again, same thing with the smart contract platform. So we have support for a bunch of ledgers. So if our own implementations as well as Ethereum and Cosmos-based ledgers in general, but there's nothing stopping you from adding more because the APIs which support that can be extended. You can load in additional support and can actually share it with the rest of the community. So that's how we think about these two points.
I'm just seeing a note there saying we need to wrap in a couple of minutes, but there are some quick answers to some of these questions. Who delivers the computational power? I sort of answered that in the chat earlier, but basically you do, or if you don't, then the cloud can. And certainly when it comes to things like the agent builder, which we showed, like drag and drop, and you press a button, we would want to provide a service so that that can be handled for you entirely. And I think that kind of thing is important as well. And we're not the only ones who would be able to provide that kind of service. But of course, if you want to run these agents locally on small devices like Raspberry Pis, or your local computer, or a cloud thing that you own, virtual server or whatever that you own, or elsewhere, that's up to you. If you've got a computer that's capable of running it, then you can run your agent there. And we're working very hard all the time to ensure that the number of options available to you is going up to do that, and the computational power required in order to run an agent goes down. Every time we do that, we dramatically increase the potential population of agents that can exist.
There's one key thing here which I just want to raise just to make sure no one gets confused. So sounds like AA could be slow as they run on blockchain. What kind of throughput can we achieve between two agents? So it doesn't run on the blockchain. It uses ledgers, right? It runs, as Toby was saying, in different environments. Therefore, there is no fundamental, from a design perspective, scalability problem here.
And are we out of time, or can we do one more? What do we reckon?
Well, yeah, should we do the, well, we actually did, so agents can interact. We did that.
Yeah, we did.
Do you want to say something about manufacturers?
Car manufacturers? Obviously, we can't talk about any private conversations that are going on, but this is technology. I think I popped a link in when that question came up to a blog post about the signs demo that we built for self-driving cars. But there are also other reasons why this might work, particularly in connection with our collective learning as well, where manufacturers can potentially share information to build a collective model, but without having to disclose anything that's confidential or private to them. But also, of course, cars are absolutely massive metal boxes full of sensors and devices, that all of which are useful, all of which could contribute value to people nearby and elsewhere, and none of that value comes to you, but there's no reason why it shouldn't. And if it isn't going to you and it's going somewhere else, then surely that should make the cost of the vehicle a little bit less for you. But it's about you being in control of that utility value. So yes, I mean, we've often looked at vehicles, but also originally drones as well, as effectively, well, for the case of drones, flying platforms full of other agents, all of which can potentially talk to each other in order to get the most value out of what is possible to do. So yes, there are always ongoing conversations, always some very interesting things going on, looking at how autonomous economic agents can get the best out of the value that's already there for people.
So the last, maybe perfect last question is, why should I create my own agent now? I have a very clear answer to this. We're early in a growth of hopefully a very big ecosystem. You'll never get as much of our time as later, because now we work really closely on all these problems. So jump into the developer Slack and we'll help you out.
Yeah, that is the perfect answer. We should end there. If you want our undivided attention, now's a great time to build agents. And if you're building them anything relating to the DDN or any of the other applications that we've talked about today, then you can interact with the agents we've already got, and you can do that now. And I think that's pretty exciting, because we'll get ideas, you'll get ideas, and we'll all work out how to get more value out of a future population of autonomous economic agents, making our lives easier. Thank you so much for being here, and thanks very much for listening in and all the fantastic questions. Any of the questions we didn't answer, we would love to do so. I guess we'll collect them and see what we can do. If you're there on Telegram, feel free to ask us there, or on the developer Slack, and ask us there, and we'll do what we can to get back to you as soon as possible. In the meanwhile, come build some agents and join us in all of this. And thanks very much indeed.